I notice that this is a isosceles triangle, 45, 45, 90, so this one is also going to be 141.4. Now, since that's going down, it's actually going to be a negative 141.4. Okay? And so now that I have that broken into pieces, let's go ahead and list the information that we have, both x and y. Okay, so we know that our initial velocity in the x direction is 141.4 meters per second. Okay, also the initial velocity in the y direction, this one will be negative 141.4 meters per second. Okay, and now let's see, we have the vertical displacement, right? Because the bomb's going to be dropped from up here and it'll end up down there, so it's going to drop 1,000 meters, so negative 1,000 meters. I also know the acceleration in the y direction, which is negative 9.81 meters per second squared. Now I know a couple of things about the horizontal direction. I know the final velocity is also 141.4 meters a second, because the only thing causing that bomb to accelerate once it's been dropped off the airplane is gravity. And gravity only works up and down, which means that it doesn't affect the horizontal motion. They're independent. And so my acceleration in the x direction will be 0, and my final horizontal velocity will be the same as the initial. Okay. Now we know that we can't use this information right away to find the horizontal distance because our acceleration is 0, and so anytime we try to plug it into the equation, the 0 times the displacement is going to cancel the displacement out, or the 0 times the time is going to get rid of the time. And so I actually have to start by using my y information to find time. And so we're going to use this equation right here, y equals the initial velocity times time plus 1/2 acceleration times time squared. Alright, so we've got negative 1,000 is equal to the initial velocity, which is negative 141.4 times the time plus 1/2 times negative 9.81 times time squared. And let's go ahead and rearrange this a little bit. I'm going to go ahead and multiply the 1/2 times the 9.81 and then put that at the front. And so it'll be negative 4.905 t squared. Then next comes the t, minus 141.4 t. And then I'm going to go ahead and add 1,000 to each side. Okay, so add 1,000, add 1,000. That means this is going to be 0 is equal to that. Now that my quadratic equation is equal to 0, I can solve it by factoring, which will be difficult because I have decimals there. I can solve it by using the quadratic formula, which is difficult just because it's a mess. And then I can also use what I'm going to do, which is going to be graph on the calculator. And so I'm going to go ahead and come to my calculator here and put in the y equals, and I can go negative 4.905 x squared minus the 141.4x plus 1,000. Okay, and then let's go ahead and graph that. And now you'll notice that when I graph it, I'm in the standard zoom. So if you don't see what I see, you can press zoom 6, and that will put it in standard, which will be 10 by 10 in all 4 directions. Okay, you can see that the graph crosses right here. Now it actually goes up and curves around and crosses somewhere down here as well, but I'm not worried about the negative time, right? I'm only worried about the positive time right here. And so I'm going to calculate the 0 here because I want to know when the equation is equal to 0. So let's go second trace, which is calc, and then we'll calculate number 2, the 0. And so it wants me to be left bound. So right now I'm at x equals 0, which is definitely to the left of that, so I'll push enter. And then now it wants me to go over to the right, so I need to go over to the right. And see how the y values are getting lower? Right now it's up here somewhere, but if I go enough to the right, now it's jumped down below. Now it's at y equals negative 16, so it's down here somewhere, which means I'm now to the right of that point. So we'll push enter. I don't really want to guess. I want the calculator to figure it out. So my time is 5.87. Okay, 7 seconds.